combine x. You have x here and x here. To do that, you need x on the same side. So what happens here? This right here, let me get it here, this piece right here gets moved right over there. And then what do you do with the two things on the right here? What do you do with these two things? What gets factored out? The x gets factored out, and then you divide both sides, and you end up with this right there. So this is about as annoying as it gets because the bases are different to begin with, and they're not even vaguely nice to each other. So over here, that's a slightly different challenge. Let me just pause here for a sec. Are there any? This is pretty cool. On this side, it's what's annoying about this one, or what's different about this? Well, there's a ln in the exponent, right? What was done to both sides? The ln was taken of both sides. The ln was taken of both sides. So there's actually an intermediary step in here. If we do the ln of both sides, we have ln of 2x minus 1 equals ln of e to the ln x squared. What can you do with the exponent? What can you do with the exponent? Bring it to the front, so you still have ln of 2x minus 1 is equal to ln x squared times what? ln e. We brought it to the front. But what is ln e? Oh, look, we're here. What happens to the ln e? What is ln e? I'm not asking a rhetorical question. It's 1, right. So you then have, once you get rid of that, you have this statement. You have ln of 2x minus 1 is equal to ln of x squared. So what you do to find the inverse function is you replace x with y, or you switch the variables, and then you solve for it. So we have, in this case, this is the original function right here. So what's the first thing that happened? It now turned into t equals 1 plus ln y. So now what do we solve for? What's happening here? We're solving for? Solve for y. So all you do is you switch the variables, you replace all the x's with y's or y's with x's, or in this case it's t's and y's, right? You replace them, you switch them, and then you solve for the original variable. You solve for the original variable. So in this case, the f inverse is e to the t minus 1. Does that? So what's another way to write that? Instead of f of t, let's call it y. I think that's what the problem called it. So this is the original function. Y equals 1 plus ln t. So what's the first step? Replace the variables with each other. So you have t is equal to, so we do the switch step. T is equal to 1 plus ln of y. What are we trying to do now? We're trying to, what's our goal now? Isolate what? What do we want to isolate now? We want to isolate y. That's what we want to do right now. We want to isolate y. So what's the first thing we subtract from both sides? So we have t minus 1 is equal to ln of y. At this point, is this in log form or exponential form? This is log form. This is log form, right? So what do we want to turn it into? What do we want to turn it into? What do we want to? Thank you. We want to turn it into exponential form. So you might remember if you have log base a of x equals y, that's the same thing as a to the y is equal to x. Remember the circular thing here? The circular thing? ln is log base what? E. Log base e of y. So you start with the base. It's e to what power? What do we raise e to? What power do we raise e to? E to the t minus 1. So it's going to be e to the t minus 1 is equal to what? Is equal to? Y. So what is our inverse function? Y equals e to the t minus 1. 0.05, and it's 1 year, so it's times 1. Someone do that on their calculator for me. Do that right now on your calculator. 5.13% interest rate. Do you agree? Do you see what? How do you turn 100 into 105.13? You multiply by 1.0513. Here's the thing. What was our continuous interest rate? 5. What's the effective interest rate? 5.13. 5% continuously is the same thing as 5.13 once. Why is this going to be higher than this? Why is this going to be higher than this? What's more powerful, continuous interest or simple interest? What's more powerful? What earns you more money? Continuous interest, right? So a lower continuous interest rate gives you the same amount as a higher regular interest rate because interest is being compounded in this one. someone says, for example, okay, I'm going to give you a bank account. It's 5% interest continuously, or it's 5.1% interest, simple interest, regular interest. Which one do you take? If I gave you 5% continuous or 5.1 simple interest, which one should you take? The continuous, because we know that this is actually 5.13. Can little differences like that make a big deal? They make a huge deal, right? So this is the effective interest rate. You compare what the growth rate would be in 1 year. So let's take a look at this. Right here, let's take a look at this question right here. P equals 25E 1.25t. In terms of the continuous interest formula right there, in terms of the continuous interest formula, what's the initial amount right there? What's the initial amount? 25 is the initial amount. So let's look at this. 25 is the initial amount. And then this is E, and this, oh, that's R right there, 1.25, right? So what did we do to do this one? We took 1 year. We looked at what happened in 1 year. So what should we plug into this? What do you want to plug into this? What did we do down there? Plug in 1. So just do P of 1 and see what it is. So everybody take out your calculator. Everybody do this. P of 1 equals 25e to the 1.25 times 1, like that. When you have it, raise your hand. So we do ln of what? 1.15 is equal to ln of e to the question mark. What do we do with the question mark?
Make it x, or make it another.
Bring it to the front. So you have ln of 1.15 is equal to question mark times ln e. But what's ln e? 1. So we have ln of 1.15 is equal to question mark. Can you tell me what that is? 139. So what does that mean? It's a 13.9%. Should the continuous interest rate be less than the effective interest rate? Should the continuous, yes. Why? Why? These two, what we're saying is 15% once is the same thing as 13.9 continuously. We're saying that 15% once is the same as 13.9 continuously. But what do we know about continuous interest? It's, what is the phrase? It's more what? It's more powerful, right? It makes more money faster. Yeah, it's more compounding. I like that actually. So should the continuous interest rate always be lower than the effective interest rate? Yes. Yes, it should. Okay.
But it's still more powerful even though you get the same amount at the end of the day.
Correct. But it allows you to compare now. So I could say, what's better, everybody? So given what's on the board, ready? I want to ask you a question. What's better? 14% continuous or 15% simple? 14%, right. Now you can actually compare these things. But unless you've done this, would you know that off the top of your head? No, not necessarily. Like you know that continuous is more powerful, but how much more powerful? Well, this tells you how much.
So is it always going to be more powerful? Even if it's...
If it's the same number, yes. If it was like, do you want 15% compounded continuously or 15% simple interest? Yes, you always go compounding, right? But you can always sacrifice a little bit on continuous because it'll make it up because it's more powerful. I like that phrase. So. Okay, so let's jump to, we did a decay one. Let's do this real quick because I need to make sure you remember how to do this. Everybody stand up. You need to watch this. I know you're going to want to touch your calculators to do this, so I need to make sure you don't. You remember doing quadratic regression?
No, I don't know what that means.
Okay. If I put 2 points, let's say I put like 3 points on a board like this, I can say, what's the line of best fit? You could be like, oh, it's something like this, right? Something that's close to all of them. That would be a linear regression, coming up with the line of best fit. Let's say I had some points that looked like this. I could come up with a curve. What kind of regression would that be? Quadratic regression, right? What kinds of functions are we looking at right now? Exponential. We're looking not actually polynomials, we're looking at exponential functions right now. So what exponential regression can do? Exponential regression can do? What am I going to do? I might have been watching Mean Girls earlier this week, so I apologize. Who? Did anybody remember Tina Fey is in Mean Girls?
Yeah.
Remember that?
She wrote it.
I'm on record. I'm very sorry to the world. I didn't remember that Tina Fey wrote Mean Girls. I thought it was based on a book. It is based on a book. But anyway.
Yeah, it is.
She adapted it? Okay. Do I get a little bit of credit back, you know? Okay. What's the derivative of pi squared? What's the derivative of a constant? What's the derivative of 5? What's the rate of change of What's the, you're like, what's my name? That was the best blank look right there. Where he's like, pass. What's the rate of change of something that's not changing?
Nothing.
Zero, right. So what's the derivative of pi squared? 0. So the derivative of that is 0. What's the derivative? Oh, pi to the x. Can someone tell me what the derivative of that's going to be? ln of what? Pi times what? Pi to the x, right? And then what's the derivative of negative, oh, x squared? Come on, you can tell me. What's the derivative? No, what's the derivative of x squared?
ln of pi.
No!
Oh.
The derivative of x squared. What's the derivative of x squared?
Oh. 2x.
2x. Ah, congratulations. Okay, the point I'm trying to make is this. I'm gonna break this down a little bit better. What's the derivative of pi squared? 0. What's the derivative of this?
Yeah, how do you know?
Why is it 0 again?
Is there a variable in pi squared?
No.
Pi squared is a number, right?
Oh.
What's the rate of change of a number? You're like, there it is. Oh, ding. There we go. Are you with me so far? No, the question is set up specifically to get you to do that. Because many people are going to write 2 times pi as the derivative, right? That's not the derivative of pi squared. Okay. What's the derivative of pi to the x power? Well, we just learned that it's what? ln of pi times what? X, pi to the x. And what's the derivative of this?
2x
Minus 2x. Oh, and then this one right here, you're like, oh my god, I don't remember that. But what's that equal to? That's 3 times x to the what?
Negative 2.
-2. So what's the derivative going to be?
Negative 6.
-6x to the what? Negative. You go down 1.
Negative 3.
-3. So far we've done the derivative of the first 4 things. So what do we know the derivative now is? F prime of x is equal to 0 plus what? ln of pi times pi to the x minus what? 2x minus what? 6x to the -3. But are we done yet? Why aren't we done yet? We have this thing right here, the green. We still have the green right here. Okay. So how do you go about doing that? Well, is there a hint over to the right? So let's say g of x is equal to 8 times 8 to the x. Does anybody want to tell me what g prime is going to be? What does that 8 do in the front? It doesn't go away, but like, what happened up here? What happened to the 5? The 5 is just what? Along for the ride. So it's going to be 8 times what? 8 times what? What's the derivative of 8 to the x? ln of? Yes, correct. So what goes right here? Minus what? What goes right there? Minus what? Minus 8 times what? ln 8 times 8 to the x. There's our derivative. Is it long? The slope. Do we know part of the point? What do we know about the point? What does it give us? So it gives it the x value of 2. How do you find the y value? What's the y value going to be? 9. Hey, do we have the point already? We do. Exciting. Very exciting. The next one. You probably have a guess. What do you think the derivative of this is? Guess. What do you think the derivative of this is? Just guess. Take a wild guess. What do you think the derivative of 5e to the 5e? It is. But let's use the product rule. What are the two functions? What's the first function? Remember, it's y equals f of x times g of x. In this case, what's f of x going to be? 5. Yes, correct. F of x is 5. What's g of x? E to the x. What's f prime of x? What's the derivative of 5? 0. What's the derivative of g? E to the x. And do you remember what the product rule said? If they're multiplied together, it's y prime is going to be f prime times g plus f times g prime. So fill in the blanks here. What's f prime? 0. What's g of x? E to the x plus, what's f of x? What's f of x? Look up at 5, and what's g prime of x? E to the x. Hey, what happens to that first term? It's gone. So what does this whole thing equal? 5 e to the x. Did we just use the product rule? Yes, we did. So if we wanted to use the product rule over here the same way, let's look at this one again. Let's do it one more time. Let's do it one more time fully. In this case, we're going to say it's, what's f of x going to be? What's f of x? X cubed. And what's g of x going to be? 4 to the x. So what's f prime? We already did this. It's 3x squared. And what's g prime of x? What's g prime of x? ln 4 times 4 to the x. You just now, we know that y prime is equal to f prime times g plus what? F times g prime. So fill in the blanks for me. What do you get? Y prime is equal to, oh, it's the same thing. 3x squared times 4 to the x plus, what's f of x? X cubed. And g prime, what's g prime? 4 to the x. There's your derivative right there. You do the derivative of the first times the second plus the first times the derivative of the second. You can, okay. How do you feel about